Hello again. We're going to take a more in-depth look at the circuit board today. See if we can kind of figure out how it's routed, what the different sections of the circuit are. The big goal being to save the battery pack, save the solar charger, find a 5-volt bus that we can maybe power people's phones off of. And then it'd be good to find a way to recycle the GPS and the Iridium module as well. So we have a marker and a hacksaw, so I'm hoping we can kind of just say, okay, this section here is the GPS and cut it and reuse it. So we'll dive right in. We'll start by just taking a quick look again at the input power, because that's a great place to start. So here's our massive battery pack. We have 3 leads because it's 3 isolated cells or battery packs. This top one is the rechargeable nickel metal hydride, and this bottom one is a non-rechargeable alkaline chemistry. I'm not very familiar with these chemistries, but we're going to do our best. And I'll just show you where these connect here. So here we can see the rechargeable battery pack has 3 connectors, but they don't all have connector pins, whereas the other 2 just have the 2. So the way they would plug in, the 3 goes in the middle here, and we can see it power up, and then the other 2 alkaline batteries here. And so we can see, hopefully you can see from the top, that on the right of both of these we have our positive supply, and in the middle of the 3-way connector is the positive supply. Okay, and then lastly we have our solar panel. It's not bright enough in here to actually do voltage testing with this right now, but that connects to the opposite side of the board. This is a 4-pin connector, but we see that we only are using 2 actual pins. And so if we flip this over, that comes in here. And so it's really easy to look at the ground plane underneath. Whoops, it goes this way. And remember that, okay, the ground is on the right side or on the outside of the board, and the input is on the inside. Okay, so let's get this out of the way. Okay, so let's start with the solar panel, because that's actually what's going to be recharging everything and presumably feeds into the battery pack as well. So as we recall, this here is the input for the solar panel, the high side for the solar panel. And you'll see that runs off, I'm not putting my head in the way, you'll see that runs off to this pin here. I found the data sheet, and it's hard to tell because there's a lot of conformal coating on the board if the part hasn't just been lasered off. But after spitting on it and adjusting the light and all that, it's a MIC 5239. And so here on the pin diagram you can see that on pin 3 we have our input voltage, and on pin 4 we have the output. So if we check here, if all is just and right in the world, there we go. So that is actually shorted directly together. So we're on target here. Here's the decoupling capacitors, here's the feedback resistors. So that's all great. So we can take a look here and see that on pin 4 we have our output, which I believe is running to this diode 12. Okay, there we go. So now that I've scraped off the conformal coating, hopefully we'll see this with no problem. There we go. Oh! There we go. So we're hot on the case. The high side of the solar panel comes in here, runs into pin 3 of this voltage regulator, gets regulated to 13.5 volts, and then pin 4 runs into this diode, and then I'm pretty sure this goes to the center pin of our battery, charging the battery. So if I can get my probes on everything. This is great. We have our battery and we have our charger for the battery. So the output to this runs to, I think it's this diode here, and the polarity of these are not all the same. So this big thick trace here is the power bus that all the batteries then connect to through a diode. So they can't backfeed at all. So I guess just whatever battery is the highest is what powers the board. And so that would kind of be our minimum viable product for dissecting the solar charger out of this thing. So what I'm hoping to do, and I saw this off of someone else's Instructable, is kind of just, hopefully this marker shows, cut along, somewhere along here. Ooh, the marker's not so good. Nah, it's no good. But the goal would be to cut along this trace, include the trace, and then we would have a plug for the solar panel and our rechargeable battery, and that would be a pretty reliable power source for a buoy in the ocean. Awesome. Let's I'll restart this and we'll right on. So we have our solar panel. Let's just take a quick look at the pack and see what we have to work with here. It's these nickel metal hydride cells, right? I think it says that right on there somewhere. Yeah, nickel metal hydride. Each one has a nominal voltage of 1.2 volts. I don't know a lot about this chemistry, but and a capacity of 2 amp hours. You know, who knows? We don't really have I don't have an electrical load, so we can't actually test the actual capacity of this specific battery. But this is a great place to start because these are all wired up in series, and I believe there's 10 of them, 2, 4, 6, 8, 10. So this gives us a 12 volt battery with 2 amp hours. And my math here is not so good, but I have a calculator watch. No, I won't make you guys look at that. But I think if we have a Raspberry Pi, I'm going to use a Pi Zero for these projects, that's hopefully drawing maybe around half an amp and runs at 5 volts. This could let us run a project for maybe 9 hours or so, assuming you know, we had a full charge. And if we actually are charging along the way, maybe we can do even better. So yeah, I'll have to double check those numbers. That seems very optimistic. But okay, so we've taken a look at this pack, and let's look at the packs underneath. There's really not a lot to do with this. It's very frustrating that the largest pack is not rechargeable. And you can see they've really have a custom molded part for to hold all these in place. Each one's spot welded, but I don't think there's a whole lot we can do here. I'm gonna try to pop out one of these cells just so we can take a photo, but yeah, there it goes. It's funny, if this was lithium I'd be terrified, but it's like alkaline, so I just assume that it's safe, but maybe that's really not the right mentality. But yeah, Panasonic, industrial alkaline, DLR20. I assume these are not rechargeable. So I'm not sure what we're supposed to do with that. I think that, you know, the buoy probably needs to have a certain amount of ballast to float naturally in the ocean, but you know, the extra weight in the buoy might be extra upward force pulling our deployments, or on our mooring at least. So we may or may not just leave this in for ballast. That one we'll just test in the field. Cool.
To go.
Awesome. Okay, so we have a good idea for where the solar charger is. We have a good idea for what battery pack we can reuse. So let's find a few other things we can reuse on this. Looking at this GPS unit, so there's a good empty space here. The antenna is just on the opposite side. So I'm hoping that it's reasonable to kind of just trim it out. It's so much glare, I don't know if you can see that. Cut this out and you'll have a perfectly good GPS module. You know, the way these antennas work, the whole ground plane does act as part of the antenna. So, you know, you do lose a little bit of accuracy by cutting it off the rest of the ground plane, but I don't think that's really something we have to worry too much about, because we're really mostly interested in geofencing our projects, not so much getting that last meter of accuracy. We just want to know if someone's stolen it off the spot, basically. This is the L70R. So it's pin 2, which should just be out of sight to you probably, of this module. That's the transmit pin. So if we probe it across this resistor, it is common to have resistors on the signal lines of GPS modules. Come on, just give me the beep. Finally, there we go. So if we solder to this connection here, we should have access to the data from the serial port of the GPS unit. So this trace runs all the way around and actually meets up with this unpopulated footprint. So there's also another pad over here, if I'm not mistaken, that we could also solder on. There we go. So as long as we provide power to all this, we should be in good shape. And the power is going through these decoupling capacitors here, through this capacitor, this even larger capacitor, electrolytic capacitor, at the bottom. So if we took that out or solder directly to that, we should be able to power the whole thing up, tap onto that pad there, and we should have a working GPS module.